Welcome to the first lesson of our Python programming crash course. We will start with the absolute basics to get you familiar with Python. So, what is Python? Python is an interpreted, dynamically typed, and high-level programming language. It was created by Guido van Rossum and first released in 1991. Python emphasizes clean and readable code, making it an ideal language for both beginners and experienced developers. Why Python is so popular? First is because of its simplicity. Python is straightforward and the human-readable syntax reduces the complexity of coding tasks. 2 is versatility. Python is a multi-paradigm language which supports both procedural and object-oriented programming and as well functional programming. 3. Python has a massive and active user community contributing to an extensive collection of libraries and frameworks. 4. Cross-platform. Python is available on various platforms: Windows, Mac OS, and Linux. 5. Open source. Python is open source, which means it's freely available and open to contributions and improvements from the global development community. What is Python used for? Python is used in web development using frameworks like Django and Flask. Python is also used in data science and machine learning, used in scientific computing, automation and scripting, game development, desktop applications, network programming, education, and etc. How to install and set up Python on your computer. To install and set up Python on your computer is super simple. But for the purpose of this course, we are not going to be downloading Python or a code editor on our computers. We are going to be using a website called Replit. With Replit, you don't need a sophisticated computer to install Python. However, I'm going to be providing a link to a full Python course where I'll be showing you how to install and set up Python on your computer. So, without much ado, let's simply open up our web browser and then I'll simply type replit.com. And here we go. So Replit is an idea to software and it's fast. So here it says build software collaboratively with the power of AI or any device without spending a second on setup. So if it is your first time using Replit, you are going to click on sign up. So I'm just going to click on sign up. And then you can continue with Google or you can continue with email. So I'm just going to continue with Google. And here I'm going to choose one of my Google accounts which I want to use to create a REPL account. And here we go. So I'm just going to close this onboarding screen. And then we are going to see a button, create REPL. So I'm just going to click on that button. And then here I'm going to click on Python because this course is about Python language. And then I'm going to give my REPL a title. So I'm just going to say Python for beginners. So you can call it whatever you want. And then I'm going to click on create REPL. And here we go. So here you can see our REPL Python for beginners has been created, and take this as a working directory or a folder on your computer. And then in that folder, the REPL has created a Python file for me, which is main.py. So on this file, I can do a lot of things. I can rename it. I can copy the URL. And I can also duplicate or download or delete the file. So if I want to create a new file, so I'll simply hit on this icon, which is new file, So I can click on it, and let's call this script.py, and I'll hit enter. So here that I have another file, script.py and main.py. So the py basically tells the computer that this is a Python file. So every Python file must end with .py. So now you can see I have two tabs. So I'm just going to close one of these tabs so I can use the main file. And then on the left side, on the right side, we have the console. So when we write a code on the main.py and then we run the code, then the result will basically appear on the console. Now let's write our first Python program. So to write our very first Python program, I'm just going to delete this. So I'm just going to get rid of this. I'm just going to start typing my first code, and this is going to get rid of this text. So I'm going to say print followed by a parenthesis. Note, Replit do have an auto completion which pops up as you write your program, or which pops up as you write your code. But to make things as simple as possible, we are going to write this code ourselves. So we have a print and then we have a parenthesis. So, and inside the parenthesis, I'm going to put a quote inside it, and this is a single quote. And then I'm going to say hello Miriam, and then I'm going to run this. So if I click on run, and here we go, hello Miriam. So we have successfully written and run our first program. We can also use a double quote for this. So if I replace this with a double quote and run this again, and this will give us the same result. So I can go ahead and equally print a number. So I can say print, and then I want to print 25. So if I run this, and here we go, we have hello Miriam and then 25. So I can also print 2 multiply by 5. If I run this, and here we go, we have 10. Wait a minute, you may be asking, why do we have quotes? Why do we have to include a quote on this, and then we never want to include a quote on the integers? Now let's see what happens if we try including a quote. So if I put a quote, let's say we surround this with a quote, and then we try to run this, and here it gave us back what we wrote. So here you can see 2 multiplied by 5. So you don't surround an integer in a quote if you want to do a mathematical calculation. So in programming, strings are sequence of characters that are enclosed in a single or a double quote. So this is a string, and then this is an integer. So before we move to the next step, I'm going to clear my console by clicking on clear history icon, and here we clear our code. So I can also run this again, and we'll have the same results. Comments are used for documentation and explanation in your code. Comments can also be used to hide the visibility of our code. First, let's look at how we can document or explain our code. So let's suppose I want to document line 1. So I'm going to come here and then enter the hash sign, and then I'm going to write, this is my first program. So this is my first program. So now if I run this, and we got the same result. Now, Python ignores the lines that start with a hash symbol. So the Python interpreter ignores the lines because it's just for documentation purposes. So I can also write it above my code. So I can say this is how to print an integer. So if I run this one more time, and you can see that the line 3 is treated as a comment, and then it is ignored during execution. Now the second reason you may want to make comments is to hide the visibility of your code. Let's say I do not want to erase my code, but I want to hide it. I don't want it to appear on the console. So I will simply treat these lines of code as a comment. So if I put the hash symbol in front of it, and then if I execute this, and here you can see that the rest of the code has been treated as a comment. So we just have our first program, which is hello Miriam. So this is how to make comments in Python. In Python, a variable is a name that you assign to a value or an object. It's like a container that can hold different types of data, such as numbers, text, or more complex objects. Now, for example, let's say we have the number 5. Now, 5 is basically a value. So how do we assign this? Before we continue, I'm going to show you a way of turning off the suggestion by the artificial intelligence. So under the tools, I'm going to click on AI, and then here you can see autocomplete, suggest lines of code as you type. So I'm just going to disable it, and I'm going to close this tab and then go back to our console. And this is how it should be as a beginner. So we're going to type and learn everything from scratch. So we don't need an AI for now. So like I said, let's suppose we have the number 5 or the integer 5. Now 5 is a value. We want to assign it to a variable. So to assign it a variable, I'm going to say x equal to 5. So in this case, x is now the variable holding 5. So x equal to 5. So x is like a container that stores the number 5. To verify if actually x is equal to 5 or x is actually holding the number or the value 5, all we need to do is to print x. So if I print x and then we run that, and here we go, we have 5. So I'm also going to make comment this. So if we run that again, and here we have 5. So variables are essential for storing, manipulating, and referencing data within your Python program. So I can also create more variable. Let's say this is person variable, and then person is going to be equal to, in quotes, Mike. So now I can print person. So if I run the program, and here we go, we have Mike. Variables can also be used in expression. For example, I can say y should be equal to x plus 20. X plus 20. So x is 5. That means 5 plus 20. And this is going to store the result in the variable y. So now instead of printing person, we want to print y so we can verify. So if I run this one more time, and here we go, 25. We can also rename variable. Now on line 8, we have the variable person, which is holding mic. So let's suppose in line 10 we have person as a variable, and this time person is holding John. So now if we print person and run the program, and here we have John. So since Python program runs from the top to the bottom, when it gets to line 8, we have the variable person, which is equal to Mike. And then it gets to line 10, it sees, oh, person is no longer Mike, but John. So it reassigns the name to John. Next, let's look at variable naming conventions. Now Python has variable naming convention, and it states that variable names can include letters, just like we have person. It can also include numbers and underscore. For example, let's say we have another variable, let's say student score. This is going to give us an error. Student score, let's say, is 100. So you can see, even without running the code, we can see the underlined error. So this is a bad naming convention which is not going to run. So in order to separate this, we can introduce an underscore so that we can avoid an empty space. Student underscore score, or let's say student scores. So we have student, and then we have the underscore, and then the scores is treated as a variable. So we can say student underscore mark. So let's put that student underscore mark. So this is treated as just one variable, and you don't begin a variable naming with a number. So for example, 1 student underscore mark. So if I run this, so this is going to return an error. So you can see syntax error, invalid decimal literal, and this is coming from line 11. So you can see from the error, line 11, 1 student underscore mark. So but you can include a number afterward, so just like this. So if we run it, this is not going to produce an error. So let me clear the screen. So if we run that, so here we go. So let's print this and let's see if everything is working. So now if I run this, and here we go, 100. Also, variable naming are case sensitive. So let's suppose I have a variable count underscore 1 is equal to 10, and then I have another count, but this is going to start with an uppercase. So count underscore 1 equal to 10. So both are holding the value 10, and now if we try to print, or let's change this to 20. So let's say this is holding 20. So let's print the first one. So we'll say count 1, and if we run this, so here we go, we have 10 coming from line 12, which is count underscore 1 equal to 10, and let's print the one with the uppercase. If we run this, and then here we go, 20. So both are different variables. And finally, your variable name should be descriptive. So you don't create a variable and then you call it a random characters. So this is not recommended. So your variable name should always be descriptive. In programming, a data type is a classification that specifies which type of value a variable can hold. A data types define the set of values a variable can take, as well as the operations that can be performed on these values. For example, we talked about x being a variable on the left hand side, and then we talked about 5 being a value on the right hand side. So I'm going to highlight all of this and treat them as a comment by holding Ctrl and the / on your keyboard. And then I'm going to give you an example of what data type is. So first, let's look at the integer data type. Integer data type. So example of an integer data type is like age as a variable equal to 25. So 25 is an integer. So we can also create another integer data type. So let's see, quantity tt as a variable is holding -10. So this is also an integer data type. So next, let's look at a floating point data type. So I'm going to make a comment, floating point, or simply float data type. An example of floating point data type are like price as a variable, and this is going to hold, let's say, 19.5. So a floating point always have a decimal. So when you have a variable holding something that looks like this, then it is a floating point or float data type. So we can also have pi as a variable, and this will hold 3.14, and this is another example of a floating point data type. Next is example of a string data type. So a string example of a string data type are like name equal to Mike is a string data type because it's quoted. So when a character is surrounded by a single or double quotes, is a string. So we can also have maybe message msg equal to, let's say, message equal to hello Nelson. So these are string data type. Next, we have a Boolean data type. Boolean data type. And this is like, let's say we have a variable check and the variable is holding true. And then we have a variable, let's say test, and this is holding false. And make sure that the first letter starts with an uppercase. So when you have a data type with true or false, that is a Boolean. So we also have a non-value. So let's say we have check, and then check is equal to none. This simply indicates or represents the absence of a value. So, and all of these can be printed because they are all being stored in a variable. So we can say we want to print, let's say we want to print name. If I print, so we want to print name like we have. So we have name equal to Mike. If I run that, and then you can see we have Mike. So let's say we want to print check. Oh, at this time check is going to be overwritten. So let's say checking. So let's call this checking. So we print check. So here you can see true, and then let's print checking, which is going to be this. So if I run that, and then you can see none. So these are the common data types we have in Python. In future lessons, we're going to be looking at other data types such as list and others. In Python, concatenation refers to the process of combining strings together. You can concatenate strings using different methods. We are going to start using the plus operator. So we are going to concatenate two strings. So for example, let's say we have first underscore name, and this is going to be equal to Mike, and then we'll have last underscore name, and this will be equal to John. Next we'll say full underscore name, and this is going to be first name, and then we introduce the plus operator which serve as a concatenation, and then we input a string which is going to create an empty space, and then the plus operator again, followed by the last name variable. So here we have a string, and then we have a variable. We have a variable, and then we have a string separated by plus sign. Here we have a variable, here we have a string, an empty string, and then we have a variable also, and this is also separated by a plus operator. So now all we need to do is we can now print full name. So if I run this, and here we go, Mike John. So this is how we can concatenate two strings. If we do not include the space, so let's say we have something like this. If I run the code, so we'll have it as Mike John. So it's recommended we have it this way so that there can be a space between them. We can also combine strings and number. So if I turn this into a comment, and now I'm going to say age is equal to 25, and then let's say we have a message, and this is going to be, let's say, I am space, and then the plus operator, and then we have the age, then the plus operator again, and then we say years old. So if we run this, we should expect an error. So type error can only concatenate string, not integer. So here you have a variable which is holding an integer value, and here you have a string, and then you have an integer. So the plus operator used as a concatenation does not work in this case. There are two ways of solving this problem. So we need to convert this into a string. So I'm just going to surround this with a quote which we turn it into a string, and then now I can print message. So now if I run the code, and here we go, I am 25 years old. So we need to space this, and then we'll run it again, and then here we go, I'm 25 years old. If we do not want to do it this way, we can use a string function. So we'll force this into a string, just surround it using the string function. So now if I run this one more time, and here we go. Now other ways we can concatenate strings is using the f strings, and this only works in recent versions of Python, so from Python 3.6 and later. In order to demonstrate this, I'm going to clear the history and then turn this into a comment, and now I'm going to use the f string, which is going to allow us to embed expression inside string literals. So let's say we have a name. Name is equal to Mike, and then we have age equal to 25. So we can have a message variable, and this is going to use the f string. We'll start with an f later, and then a single or double quote. So I'm going to use a double quote, and inside the double quote I'm going to make a sentence. So let's say my name is, and then we introduce a curly bracket which is called a string literal. So inside the curly bracket, I'm going to pass in name, which is this name equal to Mike. So we are going to have my name is Mike, and then I'm going to say and I am, then a string literal again, and then I'll pass in the variable age. Then I'm going to say years old and full stop. So now I can print message. So if I execute this, and here we go, my name is Mike and I am 25 years old. So the string literals enables us to concatenate variables and expressions. Next, we can use another method called string formatting. So I'm going to turn this into a comment again, and now to use string formatting, we are going to create a name variable, and let's call this Alice, and then let's also have age, and Alice is 30. Next, we are going to create a message equal to, in quotes, my name is, then our curly bracket, and I'm going to say and I am, followed by this, I am years old. And then after the quote, I'm going to add a dot followed by format, the format function, and in the first curly bracket, I'm going to say my name is Alice. So the first is going to be name variable, and then we have the second one, I am, and I am. I'm going to have the age go into this. So now I'm going to add the age. We can print message. So if I run this, and here we go, my name is Alice and I am 30 years old. So what if we want to say and this? So let's try to run that, and here we have the same result. Now what about doing the same thing on the previous one? If I remove the comment, and now I'm going to say apostrophe M. So if I run this, and we have the same result. What about doing the same thing right here? So let's try that. So instead of this, so I'm going to say apostrophe, and if I run this, we should expect an error. And here we go, we have an error. So in this case, Python is basically confused because it doesn't really know which is quote and which is an apostrophe. So in order to escape this error, so we need to add a slash, and this is going to escape that error. So if we run this, and here we go, I'm 25 years old. So let's clear the screen so you can see everything. Let's run the 3 examples. If we run that, and here we go, I am 25 years old. So these methods provide alternative ways to concatenate strings in Python. And so far, we have seen that each has its own advantages depending on the specific used case. Conditional statements in Python are used to make decisions in your code based on whether a condition is true or false. And this statement allows your program to take different actions depending on the data it encounters. First, let's look at the if statement. Let's say we have a variable, age, and age is going to be equal to 25. Then I'm going to say if age as a variable is greater than 18, and then a colon. and then we'll hit enter. Now you notice where the cursor starts once we have a colon. So this is what we call indentation in Python. So our line of code has been indented. So anything written afterward becomes the body of the if statement. So we need to follow the indentation provided by the editor. So I'll continue by saying if age is greater than 18, then print. So we want to print in quotes, you are an adult. So now if we run this code, and here we go, you are an adult. So here we have a condition, if age, and we know that age is equal to 25. So if age is greater than 18, which is a condition, then the code inside the condition is going to run. So which is this? So we have a code inside the condition, which is this code that has been indented for us. So if we do not follow the indentation, it means that this code is incomplete and is not part of this condition. So basically, if we run this, it's going to give us an error. So you can see indentation error, expected an indented block afterward if statement. So we need an indented block after if statement, which is the block that will get executed. So if we run this again, and here we go. So let me clear the history, run this, and here we go. So anything that we put inside the if statement is going to run if it evaluates to true. So as it stands now, it evaluates to true. So but if I change this to a less than sign, this is not going to evaluate to true, because basically age is 25 and we are saying if age is less than 18 and age is not less than 18. So if we run this, we are not going to see any results. Let me clear the screen. If we run that again, and here you can see this line of code does not evaluate to true. So because it doesn't evaluate to true, the next indented block is not going to run because it doesn't evaluate to true. We also have if else statement. So let's comment on this again, and I'm going to create the age variable again, and let's say the age variable is equal to 15, and then I'm going to say if age is greater or equal to 18 colon, and then we want to print you are an adult. After that, I'm going to hit enter, and then I want to make sure that it's in the same line with the if statement. Then I'm going to say else colon, hit enter on your keyboard, and then I'm going to say print you are not an adult. So if we run this code, and here we go, you are not an adult. Now, why do we see this instead of the first print? We have the age variable, which is equal to 15. We have an if condition, which is checking if age is greater or equal to 18. And from the screen, age is not greater or equal to 18, but rather age is 15. So that means this block of line is not going to run. So we shouldn't expect this to get printed. So since this is not going to be printed, we have an else. So that means if this doesn't evaluate to true, then else print you are not an adult. So that is why we are getting you are not an adult. So let's say we don't have this. So if I print this, let's clear the screen. If I print this, it's going to return an empty result because this doesn't evaluate to true. So, and in programming, it's not really recommended to return an empty screen to your users. So that is why we have the else block, so that when your first statement does not evaluate to true, what next? then print you are not an adult, or print whatever we wish to print. Next, we have the elif statement, which is combining conditions. So I'm just going to comment this again so I can explain the next one. So let's suppose we have a variable called score, and this variable is going to hold 80, for example. And then I'm going to say if score is greater or equal to 90, print you had A. Next, I'm going to check for the next condition. So this is like another version of the if statement. So checking for the next condition, which is using elif. So elif score is greater or equal to 80, then we want to print you had B. Then else print you got a low grade. So now if I clear the screen and run this, and here we go, you had B. That's because score is actually equal to 80. And this is the same thing as saying equal to. So the equal to is used for comparing things. So we don't use one equal to. One equal sign, just like this, is used to assign a value to a variable. But when you are comparing things, you can use the double equal sign. So if I run this, we are going to have the same result. You had B. So basically, we are checking for multiple conditions. So which is the if and the elif. We are checking for multiple conditions. If the first condition is true, then it's going to print you had A. If not, it moves to the next condition, which is the elif block. And then if none of this evaluates to false, it's going to move to the last condition, which is else. So let's suppose we have 70, for example. So which is not greater or equal to 90, and which is not also equal to 80. So if we run this, and here we go, we got a low grade. We can also extend our conditional statements by creating a nested conditions. Let's suppose we have a variable x, which is equal to 10, and then we have y, which is equal to 5. Now we can say if x is greater than y, which we know that x is 10 and y is 5. So 10 is actually greater than y. Then we are going to write another if statement inside this existing if statement. So this makes it a nested if. So we'll say if x is greater than y, then we want to print in quotes x is positive and greater than y. Then I'm going to say else print in quotes x is not positive. So here I have an if statement and then I have an else. Next I'm going to create else, and this is going to be for the first if statement. So I'll say else print in quotes x is not greater than y. So let's run this. And here we have x is positive and greater than y. So the first condition is checking if x is greater than y. If this is true, then this block of code is going to run. Otherwise, this will be ignored and then the else is going to run. But because x, which is 10, is greater than y, then this block of line got executed, and that is why you are seeing it here. X is positive and greater than y. So as long as x is greater than y, then check if x is greater than y again, or we can say if x is greater than 0. I think that will be better. So if we run it, we will equally see the same result because x is 10. So x is still greater than what? 0. we have checked for this, and this evaluates to be true. And now we want to check if x is greater than 20. So if we run this, can you guess what is going to be printed? So let's try that. And here we go. X is not positive. This is going to be printed because x is not greater than 20. So this line will be ignored, and then this will get printed. Now let's suppose that we have y. Let's make y 20, or let's make y 15. At this point, y is greater than x. This condition will be false. It won't evaluate to true because x is not greater than y. So guess what is going to be printed? The else block. X is not greater than y. So let's try that. So if we run this, and here we go, x is not greater than y. Hope this is clearer to you. If it is not, pause the video and rewatch. If you haven't subscribed to this channel, please do well to subscribe and turn on the notification bell so you never miss a video. Thank you for joining me, and happy coding.